Good morning to all the viewers once again. Now, if you can able to recollect the last time topic I was discussing on interference is a very interesting topic, where I describe what is this phenomena of interference, and even if you can remember that this has been shown with certain clips, and then we can able to derive the relation between the constructive interference as well as the destructive interference. There now we proved theoretically that in case of the constructive interference, the amplitude of the resultant is the sum of the two waves. So, that is we have proved last time, and whereas in case of the destructive interference, the amplitude of the resultant wave will be the difference between the two waves, and this is even it is verified and proved experimentally by conducting a simple experiment. So, that is the experiment is referred as the double slit experiment. Now, here now before we can start with the experiment, so this is the conditions for the interference to take place. The first conditions I told you last time also, I am repeating it once again. The first condition is the two source must be coherent. So, this is very important conditions. So, that means there should be two similar sources in all the respects, but logically, practically speaking, it is not possible to have two source which can able to give a same amount of light. It is not at all possible. Then this phenomena, it is made possible by certain modifications. Now, what is the modification? We will see it later on. The second condition is that the distance between the sources, the two sources which you place to get this phenomena, it should be small, it should be lying at a small distance, and the interference wave must have same or nearly same amplitude. So, if this is the case, that means if the two lights which has been emitted which undergoes interference, so their amplitude must be same. If this is the case, then we can able to get a good phenomena, that is we can able to get the constructive and the destructive effects. Now, in this case an experiment is been conducted. Now, before the experiment, so I can give once again a demo here. You just observe now how to obtain this so called the interference. Now, here is, if you can imagine, that is it is a water pond. If you can able to disturb the water pond, so you can able to get the phenomena. So, that is now just observe here. Now, while this is not playing properly, okay. Now, now let's come back. So, that video is not properly playing. Now, in order to get the interference phenomena, one Mr. Young, he has conducted the experiment, and the experiment is referred as Young's double slit experiment. Now, what actually Thomas Young did is, now he has a source of light. This is a single source of light, and the single source of light, it has been split into two sources. There are two sources. How with a simple technique? The technique is, when a ray of light passes through a single slit here, and in front of that again, so there are two slits are placed. As the two slits are placed, the same light emerge out from this slit number 1 and emerge out from the slit number 2. That means the slit S1 and S2, it forms two independent source, and in fact I know that. So, this two independent source, it is been obtained from this common source. That means so these two are the coherent sources. So, these S1 and S2 are the two sources which can able to produce the interference. So, this is how we can able to obtain a coherent source from a single source. So, here is again the interesting phenomenon of this is, yeah. So, you can observe this. Now, how this a single ray of light will be split into two independent sources. When these two independent sources, if it is falls on a screen, that leads to what is called as the constructive as well as the destructive interference. So, that is go for a play. Not what about the next? No, this one, second wave.
This with water waves. I have two sources of ripples, which are basically like the two slits. When I create ripples with a single source, they travel out with circular wavefronts. Nothing particularly surprising.
We're not playing. Okay, just observe here. So, actually this video earlier was not playing here. Now, how best you can able to produce the interference pattern? Just imagine here, and here is, you can see. So, he goes on tap simultaneously. So, that means the ripple of water from one ball and the ripple of water from the other ball. So, it will able to overlaps with each other. As a result, so the constructive and destructive interference will take place. Now, here you can see that is the swollen portion of the water. So, that is, it is because of the constructive interference. and you can see there is a shade of lines of light you can see here this. So, that is it is because of the destructive interference, just see this. So, it is very interesting phenomena. It is not only that the interference could able to take place in light also, the interference phenomena will take place in almost all the types of waves. Even the interference will take place even in the sound waves also, even the interference will take place in electromagnetic waves also, and so on. Oh, Young's modulus constant. Listen. Now, observe this is again a very interesting experiment, that is the Thomas Young has gave a demonstrations that how best one can able to get the interference pattern. So, here you can see that this is a source of light, a single source of light where the light will get out of this, and there are two similar slits are being placed. From these two similar slits there is interference will take place, and as a result on the screen you can able to see the bands of, that is the bright band you can see and a dark band. The bright band it is related with the constructive interference, whereas the dark band it is being related with the destructive interference. So, watch once again. Slides. Okay. Now, I think you have seen the simple experiments conducted by the Thomas Young. Now, what is the idea which we get out of this? The idea is that, so I have shown you a demonstrations with water, where the water waves will undergo interference, and I have shown you a demo of the light waves, that is the Thomas Young experiments, where the light wave which is transferred in nature, so that will undergo what is called as interference. So, that means to have this phenomena interference, so the waves could be of any nature, even the sound also will undergo interference. Now, here suppose you want to calculate at the constructive area, when we talk about the light at the constructive area, the intensity of the light increases. Now, when you talk about in terms of energy, so there the energy will be more. Now, where at the destructive interference, where the energy is totally becomes nil. Suppose you want to elevate, suppose you want to calculate what could be the strength of the energy levels and all that. So, then this expressions it has been very important. So, this is an expression to calculate the fringe width. What does this fringe width stand for here? The fringe width we mean here, it is the distance between any two consecutive bright or the dark fringes in an interference pattern is referred as the fringe width. So, whereas in order to have these derivations, so what you can start up is, let us imagine that we have a two source of light. Let us imagine that a two source of light, let us say that is
yes sir, full Rajkumar style.
So, imagine this is the slit, this let us say this is S1 and S2 are the slits. Let D is the separation distance between the slits. Then let us place a image screen quite opposite to this. Let the distance between is say D. This distance should be set in such a way that it should be greater than the small d, that is the distance between the two slits. Now, as you know that as the light from the S1, say it will falls on a screen to a point say P. This is the light falls from the source S1, and whereas one more light from S2 it falls to the same point from S2. Now, this slits, let us divide it exactly in the mid. Let O represents the middle point of this distance D. Now, let us join this with the dotted lines here, and similarly you can join this with the dotted lines here. Then you notice that let x is the distance of the point from P from O. Now, since the distance between these two slits are taken as D, that means this distance, say it is D divided by 2, similarly this distance is also D divided by 2. Let these 2 points are E and F. Now, just see the here is we are talking about the interference. I mean, in case of interference, the two ways should meet at some point. So, here this is the first way traveling here, the first way goes to this, and this is the second way. Let the second way it will travel more distance. See, you can see that second way will travel more distance compared to the first way. Now, that means let us try to find out what is called as the path difference. The path difference now between this is it is given by, that is, let us say A and B are the points of the sources. The path difference is given by, it is BP minus AP. Let us see, this is denoted by letter theta. There is a path difference. Now, we want to find out this path difference. Now, by considering these triangles, that is, you will get a triangle here A P E is one triangle related with the source S1, and whereas another triangle is, that is, B P F related with this source S2. Now, let us try to find out. Now, let us consider the triangle. So, that is A P E. So, in this triangle, let us apply your Pythagoras theorem. Then, as per the Pythagoras theorem, that is AP square is equal to, this is AP square is equal to, that is AE square now plus PE square. Now, substitute the value for this AE square. AE is almost it is the distance between the source and the image screen, now which is we have taken as D. So, that means this is nothing but D square plus then P is this, now which is nothing but see, look at here. So, from P to O is X, then again from O to E is D divided by 2, that means the entire distance, that is X minus this. So, this is X minus D divided by 2 whole square. Now, call this is as relation 1. Now, similarly let us try to find out the value of BP, that is what we require here. Now, again, now consider this triangle. So, that is B P F. Now, apply your Pythagoras theorem, that is BP square is equal to, that is again BF square now plus PF square. Now, again just look at the figure, again BF is almost the distance between the two screen, that is written as D square plus, and this PF square you can write as from here to here is X plus this distance. So, that means X plus D by 2. So, this I can write as X plus D divided by 2 and whole square. So, there is a square. Now, let us call this is as 2. Now, so expanding this, So, using that is a plus b whole square formula, a minus b whole square formula here, and adding up these two, so that it results in. So, what is the result we can able to get here is, now let us consider now let us consider the relation, that is bp square minus ap square. Now, that is given by, that is the value of bp square, that is d square plus x plus d divided by 2 whole square with a minus, then put a square bracket here, then again same thing d square plus x minus d divided by 2, it is whole square with a closing bracket. Then if you simplify this, so this can be written as, it is d square as it is. Now, if you apply a plus b whole square formula, that is a square plus b square plus 2ab, by doing so, so I get here is, it is x square, that is a square, plus b square is, that is d by 2 whole square, it is d square divided by 4 plus 2ab, that is 2x into d divided by 2. Then again with this value keep minus as it is. Now, follow the square bracket, then if you can expand that, so d square as it is plus, now in the bracket, now it is in the form of x minus d by 2 whole square. Now, here you can use a minus b whole square, again the expansion of this a square plus b square minus 2ab. So, expanding, that is x square plus d square by 4 minus 2x into bracket into d divided by 2. Now, next step is, now remove this square bracket by multiplying this throughout, then by doing so, so what do we get? This is equal to, so d square as it is, x square as it is, plus d square by 4 as it is. Here this 2 and 2 get cancelled, here also it goes, you left with plus x into d, multiply with the negative minus d square minus x square minus d square by 4 and plus x into d. Now, here, so everything get cancelled, so this goes here and left side remains these two, now which is nothing but 2x into d. So, this is the final results what we get. So, that is now we want to find out only, that is the phase difference. To obtain this phase run, so now look at here, this is, we can split it as, so that is we can split this as, that is bp square minus ap square, this I can write as, it is in the form of a square minus b square. So, this I can write as bp minus ap into bp plus ap. Now, what we are interested? We are interested only this. So, this value we already obtained, it is 2x into d, and now we are interested in this. Now, this is nothing but theta. Now, this you can transfer it here. So, that is theta is equal to, it is, that is 2x into d divided by, it is bp plus ap. Now, what is bp and ap? Just if you can look at the figure. So, there, suppose let us imagine here, if the distance between the image screens and that of the source, if it is large enough, then this bp and ap are almost equal, that is bp is equal to ap and that is equal to, say, the d, which is the distance between the source and the image screen. If that is case, then theta is equal to 2x d divided by 2 into capital D. Here this goes, then you left with theta is equal to x d divided by d. So, so this is the phase difference which theoretically we obtained. Now, the phase difference for the bright fringes, so it is given by theta is equal to n into lambda. Then if you can equate these two, that is this also theta and this is also theta, then you get around x d divided by this capital D is equal to n into lambda. Now, what is x? X is nothing but it is the distance of the bright fringe from the central spot. So, we are interested to find out this only. So, hence let us assume like that. So, there are some n fringes are formed. So, there may be a fringe pattern is like this, and there are many fringes, and let us imagine this is the dark fringe, and here let us say that this is the bright fringe, or you can imagine this is a bright fringe or this is a dark fringe. Now, here is, so there are, let us say this is the center point, this is a 0. So, this is a x1 is the first fringe, x2 is the first fringe, x3 is the first, and so on. Let xn is the nth fringe. So, now let us try to find out for the nth fringe that x value, that is nth fringe is equal to, it is d into n lambda divided by d. Suppose you want to find out the subsequent fringes, that is n minus 1, so and so on, that is s n minus 1 fringe is equal to d into n minus 1 into lambda divided by d. Now, this is the expressions. Now, suppose if we wanted to find out, that is what is called as the fringe width, that is what we are interested in, and the fringe width is equal to the distance between the consecutive fringes. Now, suppose if you take xnth fringe minus xn minus fringe, if you can substitute the value, then finally you get this difference. It is generated by letter beta, that is the fringe width, and finally we get fringe width is given by d lambda divided by small d. So, this is the final expression for the fringe width. So, now you just observe here the fringe width, it is directly proportional to, that is number 1, you observe that beta, it is directly proportional to the capital D. What is capital D? It is the distance between the source and the image screen. So, that means if this distance between them is large enough, then the fringe width it increases. And the second is the beta is again this directly proportional to lambda. So, what is lambda here? Lambda is the wavelength of the light. If the wavelength of light is large, then the fringe width also being large. If the wavelength of this light falling to get this interference is small and the fringe width is also less. And third is, and the fringe width, it is inversely proportional to the small d. What is small d? It is the distance between the two screens. Now, since d is in a denominator, as you know that if the value of the denominator increases, that means the S1 slit and S2 slits are placed at a very large distance, then the value of the beta will decrease, the fringe width will, it becomes small. If the denominator is less, that means this will increase. So, that is it is advisable, suppose you want to have a fringe pattern which to be observed, and see that the distance between these two screens, that is the two slits, it should be placed at a smaller the distance. Smaller the distance, so better is the fringe width, we can able to observe this. Now, this is a very important expression. So, where we can able to calculate this fringe width, and this screen, so which I have shown is actually I made a derivations. Now, it is nothing but this, and then so this is similar to that, and finally, so we got this expression, that is beta is given by this expression. Now, some of the applications of this interference patterns, you can see it here is, when you observe this the color of the peacock, now where you get a beautiful colors, that is the blue and the green color, it is because of the constructive interference which takes place at different angle. Now, because of that you can see the color more blue color and more green color. It is because of the constructed interference. Whereas, if you look at the oil floating on the water surface, again you have this, it is because of the interference of light. Now, I hope you understand what is the phenomena of interferences. Now, you have to study one more phenomena that is related with the wave nature of the light. So, that we call it as diffraction. Now, what is this diffraction? Diffraction, again, it is a very interesting phenomena exhibited with light. Whenever the light falls around the sharp edges or the sharp corner, and the light will able to acquire the obstacle. So, it will encroach the obstacle. So, this phenomena is called as diffraction. This phenomena of diffraction, it was being observed by Grimaldi long ago. In the year 1665, Grimaldi was the first person to observe, when the theory of light was not properly was explained. So, even in 16th century only he said that, so this phenomena may takes place. What is the concept behind in this is, the concepts are very simple. So, that is, now suppose if you can imagine that the light falling, this is, imagine there is a slit here. If this slit is large enough, if you allow the light to fall, if the slit is large, then the light falling it also comes away in the same direction. This is the direction of the light. So, no phenomena takes place. Now, suppose if the slit, it is made narrow, the slit is made so narrow, then what happens if you illuminate this slide by light, the light passes, as it comes in contact with an obstacle. So, there is obstacle here. So, it has to pass through. Now, how would it pass through? It will be like this. It is in a concentric circle. So, it will try to encroach the entire object. Now, this is as simple to understand, that is, as you know that if you go to a pond of water, then you just throw a stone or a pebble, you will find that the ripples will takes place, and this ripples it able to encroach the entire surface of the water. Now, here also in the same way, it is a natural phenomena. Now, here this slit or the hole, you can call it hole or a slit, is so large, it will allow the entire light to pass through. Whereas, here the object is so small, the light will pass through, but whereas it will try to encroach the remaining part of the light, it will try to fill the gap of this, right. So, this encroachment of the light, now it is, we call it as diffraction. So, this diffraction, it is defined as the bending of the light around the objects, but provided the object should be, it should be almost or incompatible with the size of the light. If this is the case, then only the phenomena of diffraction will take place, otherwise this phenomena does not take place. I can show you this. Show me the diffraction pattern. Diffraction. This one, like. So, this diffraction is so interesting that it is not related with certain phenomena. This has been present in nature. Even if you can observe the CD or the DVD, you can find there are multi colors you can see. So, these multi colors, it is because of this diffractions. Now, you just observe here, you take a blade, as you illuminate the blade with the light, the sharp edges, you can see the sharp edges here, these are the edges you can see, notice here, here the bending of the light will take place. The same bending you can see if you can have a small object and the object is totally been encroached by this kind of pattern. So, it is because of this what we call as diffraction. Now again there is one more interesting phenomena here, you can notice here. Now look at this slit, this is the slit. If the slit is so narrow, then the encroachment of the light will take place. So, this leads to a diffraction. If this slit is so wide enough, then the same amount of light will flow in a same direction. So, you will not get any effect. Now, it is now still the slit is, see, now the slit is made wider and wider, and the slit now it is narrow and narrow, the entire thing, see, the light will encroach the entire object. Now, here the slit is wide enough, so the light will not encroach. So, it will have what is called as a geometrical path it will trace. If the now this is also the some of the clouds when you can observe. Now, see this, the clouds here, that is the light will get diffracted here, because of that the other part of the light, front side will be dark and the other part you can is been illuminated. See all this is because of the diffraction of light. Go back. So, now I think some of the concepts, some of the experimental phenomena which has been present in nature, I think you observe. So, now this diffraction, as again I will repeat this, to have this diffraction, the size of the object, you should be comparable to the size of the wavelength of the light. So, then only this phenomena will takes place, otherwise this phenomena does not take place. Now, this diffraction, it has been classified into two types. One type of diffraction, it is referred as what is called as the Fresnel diffraction. Another type of diffraction is referred as Fraunhofer's diffraction. Now, what is the difference between the Fresnel's and the Fraunhofer diffraction? Now, in case of the Fresnel diffraction, the source, this is the source, and the source and the source and the screen. So, they are being placed at a finite distance. So, when the source, that is the light source, and the screen, if they are being placed at a finite distance, if the light falls on a obstacle, in this obstacle will have a small opening, a small aperture, then what happens? The light will bend in the form of a spherical or a cylindrical waves. So, that means the light will can able to encroach the entire obstacle. So, this leads to what are called as diffraction. So, this type of diffraction is referred as Fresnel's diffraction, and similar to that we have one more is the Fraunhofer diffraction. In case of Fraunhofer diffraction, the source and the screen, that is light coming from a faraway place, it is coming from a, say, from a infinite place, faraway place. To obtain this infinite place, now what you can do is you can use a telescope also. You can focus the telescope to a far away place, and where the incident light it comes, and if this incident light it falls on an obstacle. So then then what happens, the light is coming, say the parallel plane waves are coming, and these it can pass through. So again the image is formed at a very infinite distance. If this is the case, and this we refer as what is called as the Fraunhofer diffraction. Now what is the difference further between the two is, in case of the in case of the Fresnel diffraction, the diffracting obstacle is at a finite distance from the source and the object, and whereas in case of Fraunhofer diffraction, the diffracting obstacle is at an infinite distance from the source. So this is the difference. And second is the incident wave, the light which is falling on the obstacle. So either it could be a spherical wave or it could be a cylindrical wave. Now whereas in case of Fraunhofer diffraction, the incident light should be a plane wave. So because the light has to travel from far away, that is at a infinite distance, so definitely so the light may not be either spherical or cylindrical, it is nothing but the plane waves. The next is, now in case of the Fresnel diffractions, no lenses are used because the distance between the obstacle and the screen is placed at a finite distance, it is placed at a very small distance. So further there is no need to have these lenses to converge the beam on the screen. So hence no lenses are used to form the diffraction pattern on the screen. Now whereas in case of Fraunhofer diffractions, now the light is coming away from the far away place, and even the image is being formed at a infinite distance. Now suppose you want to get the image, then the lenses are generally used to produce either the incident plane waves or to capture the diffraction pattern on the screen. Now again interesting, in case of the Fresnel diffraction, now whenever the diffraction patterns takes place, so we may get the fringe patterns. So in the fringe pattern so what we observe is, that is the center is the bright, and the brightness away from the center it goes on decreases. So that is what we will observe. Whereas in case of the Fraunhofer diffraction, so it is being seen that the center of the diffraction pattern is always be bright. Now finally, now in case of Fresnel diffractions, so when the spherical or the cylindrical wavefronts are used, so here then how does the diffraction will takes place? Now from that there is again a secondary wavelet will be formed, and this secondary wavelength will try to interact at the aperture. As a result, the diffraction is being obtained. Now whereas in case of Fraunhofer, there are plane waves are used, and these plane wave fronts, so they are in phase. As a result, so whatever the image which is being formed, and this image almost resembles the obstacle. So these are some of the differences, and further the diffracting surface. And now this phenomena of diffraction further it has been analyzed by one Mr. Huygens. Now according to the principle adapted, what we called as the principle of wavefront or Huygens principle of wavefront. No, this is only to explain, that is, now the geometrical or the cylindrical shapes of the wavefronts. Now what could be the reason why we can able to obtain the geometrical or the cylindrical waves? No, so the Huygens has explained. Now, according to the Huygens theory, whenever the light falls here, it spreads in all the direction, the light gets spreads in all the direction. So, there is a possibility that at some point, so this light and this light and this light will be it will be form a part of a circle. As a result, so from here again it can able to produce further the secondary wavelength. So, that is called as the secondary wavelets, and further the collectively all these wavelets it forms what is called as the secondary wavefront. So, this is the principle so given by the Huygens. So, he says that each and every point in the primary wavefronts it acts as a source of disturbance. As a result, in turn it can able to generate the secondary waves in all the directions. Now, further he says that the secondary wavefronts which are spherical or plane in shape always moves with the velocity of light. So, that means the speed or the velocity of the primary wavefront and the velocity of the secondary wavefront is almost same. The secondary wave travels with same speed as that of the original wave. The envelope of all the secondary wavefront is known as the secondary wavefront. So, that means even a small, as I told you, so the light will get scattered here, and these are the primary wavefront. So, at this point there are small what we called as the wavelets are formed. Collectively this wavelet it leads to what is called as the secondary wavefront, and this could be the reason that the diffraction will takes place. Now, how do you find the diffraction pattern with the different lights? So, it is been seen that if you can use a monochromatic source of light, and the diffraction pattern it consisting of a bright and a dark bands of unequal width, whereas in case of interference, so you get the same pattern, but there the band width of equal, and in this case it is noticed that the center pattern is always be bright, it is having a maximum intensity. As you move away from the center, the intensity of the light decreases. So, this is when a monochromatic light is been allowed to undergo diffraction. Monochromatic light, that means, say for example, if you can use a laser light. Now, suppose if you can use an ordinary light, say a white light if you can use, then you will get the diffractions, but the diffraction pattern what you get it is of different colors. Now, in this case the center maxima will be bright, while the others are in different colors. So, this is what we can observe with different lights. Now, suppose if for the interested students, in order to obtain this so called the diffraction, I can give a interesting that is so that you can able to build and you can able to enjoy. So, that is what you can do is you take one empty halo a cartoon bigger enough, almost the say for example you can use almost the size of a fridge. Let us imagine this is a big cartoon you have. Then what you can do is one face of the cartoon, this is a box like structure, in one face of the cartoon. So, what you can do is you take two black thick plastic sheets, or say for example you can take two X-ray sheets. So, this take in, let us say this is the two X-ray sheets you can take. in the two X-ray sheets, what you can do is make two small holes, pinholes. You can make two small pinholes, and they should be very near. Make two pinholes. So, there also in this cartoon box, you cut this portion. This portion is to be removed. You cut it open and remove it. And this slit, you can fix it here. Now, see that the light should not be passed through the other part, only through the small pins where you have made a small hole. The light should fall through this only. Suppose if you wanted to observe the pattern which is being formed on the opposite of this cartoon box, what you can do is, now you can fix an IP here. Now, otherwise you can make a hole here, and then you fix up a PVC tube, say about 1 inch in diameter. You just fix it inside and you take it away, a small tube. Then these two holes which you have made with this, and you just bring it here and fix it here. Very simple. Now, this box, now you can expose to light and see what you can see. What you can see here is, if the 2 points, if they are far away, you can see only the 2 spots of light. No diffraction will take place. Then what you do is, now remove this. Now, you take one more similar piece, and there you cut it in the form of slits, in vertical slits. You cut it in the form of vertical slits, and the remaining part you should be covered by means of, say, using a cell phone tape or something like that. So that what is the purpose? The purpose is to see that you allow the light only to pass through these slits, not to pass through the other part of it. Then again you replace it here. Now, you can observe, there you can see a very interesting concept of diffraction, where if you are exposing the box to the sunlight and you get a color pattern. So, a concentric circles different. So, middle one is the white, and the remaining different colors you can observe. So, this is how the diffraction, now which has been diffraction is been obtained. So, I hope, so with this simple experiments, so you can feel satisfied that how best you can able to get the diffraction. So, next when I take up, then we have to see a certain concept in the resolving powers, either the resolving powers for a telescope or a resolving power for a microscope. All that we will try to discuss. Now, till that, so please, once again, the derivations for beta, what I said, it is very, very important as for the exams are concerned. So, you can expect the problems on it, and there may be, usually the questions will be asked in the interference, and some numerical problems you have to solve out. So, using that, so please be prepared to face the exam. So, when we meet next time, then we will discuss about the various resolving powers of the instrument. So, till that, so goodbye, take care, thank you.